Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the count good nodes in a binary tree problem. Let's jump into the description. Given a binary tree root, a node x in the tree is named good. If in the path from root to x there are no nodes with a value greater than x, return the number of good nodes in the binary tree. So for example here, we have 3, 1, 3. So the 1 is not a good node because the 3 is greater than it, but the 3 below the 1 is actually still fine because if we read up to the root, then we've never seen a 4, basically, a 4 or higher. If we go this way, 4 is good because the 3 is less, the 5 is good because the 4 is less, the 1 is bad because both the 4 and the 3 are bad. Down here we see the same thing, 3, 3, 4, the 3, and the 4 are all good. The 2 is not though, because if we read back up to the root, we stumble across a 3. Okay. I might be about to walk into some trap that I've not seen, because at first blush, this seems straightforward. I can't see why we can't do the obvious thing. Turn list of, so let me just set this up here. So basically what I want to do is a in-order traversal. Node max seen in path. If max seen, oh in fact I don't even want list, I want len. If max seen in path is none, yield node. There are motorbikes, there are planes, there are trucks. I am sorry, it's very hot here today, so I'm not closing the window, but I do apologize for the noise. Yield node, max seen in path is the max of node val, and the max seen in path, and then I want to go to yield from just up here, if node is none, return yield from self dot find good nodes, node dot left max seen in path yield from go down the right. In fact, we don't even need to do this weirdness, do we? What we need to do is ret is 0, ret plus equals 1. So rather than iterate and return all of the good nodes, I'm just going to return a count of how many good nodes I think there are beneath me. So if, in fact, or self.val is greater than or equal to max seen in path, if this node that I'm looking at now is bigger than at least as big as everything I've seen so far, then we consider it good, or I haven't seen anything at all, so it's good by default. Then I want to work out whether it what the biggest thing I've seen so far is now that I've looked at one particular node and then go down both the left and the right and accumulate those. So let's see if this works. First we'll do a bit of a typo check. Whoops. Didn't actually write down the self part. If Maxine, in fact, let's do this slightly differently. If Maxine path else node well. So I hadn't handled the case where this is non-null, not none. Sorry. Now this handles that. If this is none, just use node.val. What? Is not none. No, I don't trust my Python indentation logic. We'll have a long line. Right, that looks good. Let's use all the example test cases and make sure we're not doing anything too crazy. The only thing that will sink us now is deep trees. If the tree is more than 998 layers deep, this will fail. It'll be fine. It'll be fine. He says with no confidence whatsoever. It was fine. Fantastic. So I got a bit lucky with this one. I sort of immediately saw what the solution was. Obviously, I don't see all of them this quickly. But it's quite a nice problem. Basically just keeping track. It's an inorder traversal where you keep track of the number, the highest thing you've seen so far. Easy peasy. Right, hopefully that was interesting. Fairly short one today. I will see you next time. Bye.